Hello Internet, my name is Quinn and this is Blondihacks. So we're back at work on the grinder rest project today, and we're going to start with my favorite part of this whole build, which is the locking thumb wheels, and then we're going to get started on the platen that forms the actual tool rest itself. Okay, let's dive in. We're going to start by making these thumb wheels, and there's 3 of them, and they all serve to adjust various things. There's 2 on the height adjustment and 1 on the angle adjustment, and you can see one shown in purple there. So these are my favorite part of this build, because these things, they need to lock, because a bench grinder is a very high vibration environment, so just like a regular thumb screw isn't going to stay put. So what I'm doing is I make them out of tool steel, and I cut teeth into the back of them, and then I harden them and temper them. So they act a bit like Nordlock washers, if you've ever seen those. So when you tighten these guys down, they actually bite into the surface that they're tightening against. And because they are hardened tool steel, they're harder than all the other parts here of the assembly. So they'll dig into the mild steel brackets and stay in place against all of the vibration. So here's a piece of 01 tool steel drill rod that I'm going to make these guys out of. So we'll start by facing the ends. I really love working with tool steel. It's challenging to machine, but it comes out so beautifully. And I love all the interesting metallurgical things that you can do with it. Okay, that's looking really nice. Now I'm just going to deburr that front edge. And I'm going to mark off to cut the shoulder. So there's a narrow part, and then the thumb wheel is a little bit larger diameter. So we're cutting the shoulder here. And I'm taking very light passes, because this tool steel is pretty tough going for my little lathe. And the surface finish isn't going to win any awards here, because I'm using a very sharp nosed tool, because I want a very sharp inside corner there. And my last pass, I just wind it out to face that underside there. Okay, looking good. Next we're going to drill the hole for the threaded portion down the center. So I'll start with my number 2 center drill. And we're going to drill this tapping size. These are 1/4 20, so this is the tapping drill size for 1/4 20. And going through deep enough to get through the whole thumb wheel, plus a little extra to give clearance for the tap that's going to be run through here shortly. Okay, now we're going to tap this guy, 1/4 20. Lots of cutting fluid. And I'm taking advantage of my shop-made spring-loaded tap follower there. Makes this job quite easy. Otherwise you need 3 hands. All right, now we're going to square up the tool post and get ready to put our knurling in here. And this is tool steel, so it's pretty tough going with the knurlers, but lots and lots of cutting fluid and nice easy pressure. I tighten it a little bit and then let it run for a minute to sort of do the forming, and then tighten it a little more, just sort of giving it time like that. Helps it go a little easier. All right, it's a good looking knurl. And a little bit of deburring. I always deburr after knurling, because then knurling tends to make a nasty rough burr on the edge. And full disclosure here, I wasn't feeling brave enough to try parting off tool steel 1 inch in diameter on my little lathe here. So I took the part out, took it over to the bandsaw, cut it off, and brought it back. And now I'm facing the backside. As I said in the parting video, there's no shame in using the bandsaw sometimes. Machining is not a contest to see who can do the most masochist parting operation. Alright, and just double checking my thickness there is correct so I know if I need to face any further. Now we're going to set up to cut the teeth on the underside of the thumb wheel that are going to bite into the brackets and give it that locking action that I was talking about. So to do this, I'm going to do it on the lathe, and I'm using the lathe as kind of a spindexer. So what I've got is a seamstress tape wrapped around the chuck, and I'm using my scriber in a Noga arm there just to act as a pointer. And that's going to give me my indexing for each of the teeth. And then I've got an indicator set up on the far side of the carriage. And then I've got a sharp nose tool set sideways in the tool post, and I've got the tool holder lowered way down so that sharp point is on center. And then what I'm doing is using the cross slide as like a manual shaper. And so I'm taking light cuts because I'm putting potentially a lot of stress on the cross slide lead screw here. So I'm only going a couple thou depth at a time, and the teeth are 10 thou depth total. So you can see the basic operation that I'm doing here. I go in, I do a pass, and then I go in a little deeper. So I do 3 passes, and then I adjust my chuck using my makeshift spindexer there, and repeat until the whole thing is done. And I didn't actually do the math on making an even number of divisions. So the final result is actually doesn't quite line up, but honestly, it's perfectly fine because these are just, again, teeth. These aren't, I'm not making gears here or anything. These are just, sharp edges that are going to bite into the work. So now we get to the actual pièce de résistance. It's time to do the hardening so that the teeth will bite into their mating surfaces and not wear out. And so I'm doing that with the oxyacetylene torch. So I just heat them up to the critical temperature, which is cherry red, and I hold them there for a second, and then they get quenched in used motor oil. And I use my least favorite pliers for this operation. I'm trying desperately to kill those pliers, but they won't die. And of course they're a filthy mess after they come out of that motor oil. So after hardening them both, I need to clean them up now. So I use a combination of Scotch-Brite and a brass brush and a little bit of emery paper. It's important to get them as clean as we can because we're going to temper them now, and we need to be able to see what color they are because right now they're too hard. They're actually brittle, and so now we need to temper them back. So to do the tempering, I'm just heating them again from one side only, and I'm waiting for a straw yellow color to come all the way through to the back side. And I'm doing this with the torch far away and very, very carefully. And I'm taking frequent breaks with the heat because heat has inertia, just like physical things or electricity do. It's like inductance and electricity. So you have to give it a second for that heat to come through. And often while you're giving it a pause, that's when you'll see the yellow color suddenly appear on the other side. Because as soon as you see that yellow color, then you got to quench it in that water right away to stop that process. Otherwise, it's going to get too soft. So you're going to end up about somewhere around 50, 55 Rockwell hardness. And it's important to keep them moving while quenching because otherwise you can get a vapor barrier that forms between the steel and the water, and it doesn't draw the heat out fast enough. And if we did it right, then they're a nice, pretty straw yellow color all the way through. Now the next part we're going to make is the hinge bracket for the platen, and it's shown here in purple. And it's basically, it attaches to the top of the riser, and it has alignment pins, and it bolts to the platen to hold it in place. Now the whole platen and supporting structure is made out of aluminum because I wanted it to be lighter weight since it's up top, and I also wanted it to be a good heat sink for the grinding operations. So I actually happen to have some scrap aluminum that was machined to the right thickness already. So this is from a previous project. So I just marked out the shape that I needed for this part, and yeah, I broke a bandsaw blade. Yeah, it happens. So all I really need to do is machine this guy down to width, clean up the bandsaw cuts, and remove that kind of nubbin that's on the end there. The scrap was L-shaped because this was a failed part from my universal cell phone holder project. I made a lot of those parts before I got that design just right. But they're nicely machined pieces of aluminum, so they come in handy for other projects just like this. Yeah, we should be just about there. Yeah, I was aiming for 750, and we're about 3/4 of a thou over, so I'll take it. I never look a gift thou in the mouth. Go, Curly, go! And time to remove the mezzanine. This part was very satisfying. All this milling is being done with 2 flute end mills, which work good for aluminum. Aluminum needs a little extra space to get out of the way, and 2 flute mills will get that done. So I'm going to show you 2 ways to match an existing surface without marring it. The first way is to put a feeler gauge in there and then move the mill down the thickness of that feeler gauge. And here's another way to do it. You can actually just kind of eyeball it and get yourself real close, and then use a mechanical pencil to feel for that edge. And using a pencil rather than a scriber will avoid scratching the surface, but still allows you to feel if there's a lip there or not. And you can actually just kind of sneak up on it, going down, a few tenths at a time until you can no longer feel that lip with the pencil. And then we square up the ends. Okay, so now we're ready to drill the hinge hole, so center drilling here for this. And if you recall, the threaded studs that we made are 1/4 but they have a 251 thou shoulder on them, and that's the bearing surface for the pivot. So we're drilling this slightly undersize, and then I'm reaming this with a 250 oversized reamer. So it's a 251 thou reamer, and it's going to give us a really nice like RC2 fit on that stud. And that's important because I don't want any lateral motion in this hinge. Okay, a little test fit. Oh, it's perfect. That's one of those studs that we made earlier, so that is beautiful. Oh, I love a precision fit like that. Never gets old. No wiggle there at all. Just for giggles, here's a 251 gauge pin. You can see how it will basically fall under its own weight, just barely. Oh, it's beautiful. Okay, so now we're going to set up to drill the holes in the end, and so I'm using the edge finder here to get ourselves a coordinate system on the top of our part here. So I'm finding the center line using the half function on the DRO, and then finding the edge. And we have 4 holes to drill. The 2 on the end are threaded 440, and the 2 in the middle are actually alignment pins, because I want the platen to be repeatably alignable with the hinge. The idea is the platen can be removable and replaceable, and I also want it to be very square to the hinge, and you can't rely on threaded fasteners to do that. So there's 2 alignment pins doing the repeatability work, And then the fasteners on the ends are just there to hold things together. So the holes on the end are being drilled tapping size for 440, and then the alignment pins are being drilled undersize and reamed to 125 because I have some 126 drill rod that I'm going to make the alignment pins in, and so they are going to get pressed into these holes. So the alignment pins are a press fit on this piece, and they're a slip fit in the other piece. So they're permanently part of this. All right, so let's tap those fastener holes now. And a little test fit with our fasteners. And that's going to work out great. All right, well, that's all the parts we have time to make today. So that'll do it for this time. Thank you very much for watching. Please consider supporting me on Patreon, and we will see you next time.